So this section is 10.1, and this is going to find the domain of a square root. So let's say you have f of x equal to the square root of, let's say, x minus 1. And you want to know the domain and put it in interval notation. Okay, so the first thing I would do is go ahead and graph this, because then you could see where it starts and where it stops visually. So let's go to the calculator and we'll go to y equals and we'll hit clear. So I'm going to put in the square root of x minus 1. So second square root of x minus 1 and hit enter, and then I'll do zoom 6. And now you can see the graph visually. So it does start here. Okay, that would be my smallest domain, and then it keeps going in this direction because I need all the x values along this curve to make it continue. So if I wanted to look at a table, I can hit second table, and I can see that, oh, at 1 I get a 0. At 0 I get an error. So I cannot use 0. I can only start at the 1. And so that's where it starts. So I go ahead and I'm going to write the interval notation. So it starts at 0 at 1, okay, and then if I put 1 in here, we can see that that is acceptable. So 1 minus 1 is 0, and the square root of 0 is 0. So that works. So that's why I get 0. And so then it goes on forever, so that's positive infinity. And so infinity is not a number but a direction, so it's parentheses. And 1 is included because we do have a point at 1 comma 0. So that's bracket. So now we have the domain of interval notation for this particular function. We can do that for other equations as well. You can do f of x equal to the square root of 4 minus 2x. Again, we just go ahead and we graph it and see what it looks like visually. So we'll go to clear second x squared. We'll type in a 4 minus a 2x, and then hit enter, and then hit graph. And we see that it goes in the other direction. Interesting. And that makes sense because if I start using more and more negative numbers, a negative times a negative makes this positive, so then this becomes a positive value as I use negative numbers. So again, if I look at the table, I can see, if I look through it, that number looks okay. So where does it not work? Oh, so I can't put 3 in, because 3 would give me an error. 2 would work. Gives me 0. And that makes sense because when we do the 2, f of 2, we get 0 because that's 4 minus 2 times 2. And so that's the square root of 4 minus 4, which is the square root of 0, which is 0. So that makes sense. So my smallest number is going to be, because it's going in the other direction, so it's in negative infinity because that's where the smallest is for the x's here, and the largest this time is going to be at 2. So my interval notation is going to be parentheses negative infinity, and it goes all the way up to 2, and 2 is included for this particular problem. Okay, let's do another one. Let's do f of x equal to the square root of x squared plus 1, and see what that looks like. So go to y equals and clear it. Hit second. Oop, I wanted to clear it. So second x squared. We type in x to the power of 2, and then we add 1, and then we hit graph. And so here's what it looks like. Oh, so this one's completely different. Almost looks like a parabola, but it's not. So if I want to define interval notation for this, for the domain, it's going on forever in the negative infinity direction as well as in the positive infinity. So I'm going to need all the x values in both directions. So this one just basically is going to be parentheses negative infinity to infinity, or all real numbers. Either one is what's be acceptable in this particular problem. And so that's kind of an interesting piece on that. So that is how we do domain and interval notation, how we go about writing them.